Now let's take a look at our second exercise for today. So we already saw when I tried to ask for exercises, the first one it tried to give me, so the first attempt it made at exercise 2 was this program that I'm not ready to write. I haven't learned about what strings are yet. So I asked it for an alternative, and it offered me this, power calculator. Write a program that calculates the result of raising a number to a given power using a function. Now, this is eerily familiar. We've actually written this program already, but whatever, I'll do it again. And it suggests this, but I don't know about user input, so I'm going to sort of interpret this my own way, which is I'm going to use a variable to store the base and the exponent, and then print out 2 raised to the power of 3 is 8. So we'll copy our new updated exercise here. We'll go over and paste it in. And then we'll just do some formatting. There we go. And so when it says it should take 2 integers as input, I'm going to assume that that's just going to be this. So int base equals, I think in the example, it suggested I start with 2 and 3. So why not do that? Int base equals 2, int exponent equals 3. And one thing I'm observing that is a little bit different than the version of this that are in the existing lecture videos and probably that we've done in class by now is that it insists that we use integers. And I'm going to interpret that to run all the way through. So that is, if the base and the exponent are both integers, then I suppose the function should itself return an integer. And, I could make that assumption. Actually, I'm sort of tempted to ask it to clarify that. In the exercise, can you give the function signature for the function I will be writing in the exercise above? Let's just see what it thinks I should do. So the clarification I asked for basically amounted to, hey, I know that when I compute powers of things, sometimes I might want to compute something like, I don't know, 2.5 to the power 6. And we are able to do that. So if the base has a fractional component, we can still compute that power. So I mean, okay, I don't want to do 6, but if I do 2.5 to the power of 3, obviously that's just 2.5 times 2.5 times 2.5. Okay, but in this example, it seems to say that I'm only working with integers. And I guess the question I sort of had just now was, does that mean that, I get it that obviously the base and the exponent have to be integers because it says that, but should the return type be an integer too? And it looks like the answer is yes. So I asked it for the function signature and it gave me this function signature here. And since it gave it to me, I'm going to use it in my example. Okay, so I'm going to go and write a function with this signature. Now, what it provided, when I asked for the function signature, you'll notice it just gave me a function signature followed by a semicolon. This is a function prototype or a function declaration. If I want to actually write a function with this signature, I have to get rid of that semicolon and use curly brackets. So there we go. And if you ever notice that you're working with things like that, if you're ever asking ChatGPT for practice exercises, because I know that you wouldn't waste ChatGPT's time asking about anything that was for marks, if you were ever asking ChatGPT for practice exercises and you get a semicolon at the end of a function signature, remember that you need to get rid of that semicolon and replace it with curly brackets to write the function definition. Okay, so now I'm writing this function called power, which takes 2 ints and returns an int. And I suppose what I'm going to do in main is just call the function once. I'm going to use the exactly the same formatting that it suggested. So as I've observed before, if the exercise ever contains a required output format, you have to use it. So I better make sure I practice what I preach here. So I'm going to print out something raised to the power of something is something. All right, and then I'll print base, I'll print exponent. And in this case, just, I don't know, for some variety, in the previous exercise, I called the function directly as part of the argument to printf. Here, I'll call the function and assign the result to a variable called result. So I'll call power with base, comma, exponent, and then I will assign that to this variable result. So I'll print out the result here. Okay, now one interesting thing. So one of the reasons I asked for the clarification for what the function signature was is, as we saw in the last video, there could be a discussion later about, hey, when I compute powers, sometimes the number is really big. And maybe that means I want to use long int or long int because we know that long int and long int have a larger range. But because it told me to use this function signature, that is what I'm going to use. It's none of my business. I've been given directions. I have to follow them. Okay, so I want to now compute a power, a base to the power of exponent. Now, before I go further, I just want to do a quick test of the code that I've already written. So I'm going to have it return 0, which of course is the wrong answer, but I want to make sure that everything is being printed correctly in main. Okay, 2 raised to the power of 3 is 0. Okay, that is pretty much what I expect, obviously except for the part where the answer is wrong. Okay, so now I want to go and compute the power. So what I'm going to do here is I'm going to make a variable to store the power that I eventually compute. I guess I shouldn't just call it p, or power. I guess I'll call it just p. So p is going to start at 1, and I'm going to use the following methodology. I'm going to say, if you want to compute, let's do, I'm going to not do 2 and 3. Let's do 5 to the power of 4. Well, that's obviously 5 times 5 times 5 times 5. But I want to compute this with a loop, and the way that I think the easiest way of doing that is to do this. I want a loop that counts off 4 times, so just counts up to 4. And I want to use a variable to store the power as I compute it. So I'm going to start with just 1. So that's before my loop starts. And then at each step of the loop, I multiply what I have by 5. So first it'll be 1, so that's 5 to the 0. Then 5, which is 5 to the 1. Then I multiply that by 5, and I get 25. That's 5 to the 2. And then I multiply that by 5, and I get, 125, which is 5 to the 3. And then I multiply that by 5, and I get 625, which is 5 to the 4. So that's my idea. So I start the result at 1. I'll just put the return statement here right now to remind myself that what I'm going to return is the value of p. And now I just want to count I want to count up to this exponent and just keep multiplying in the base into my variable p. And I guess again for variety, I used a while loop in my last exercise. Why don't we use a for loop for this? So I'm going to count off. I'll use I as my counter. I equals 1. I is less than or equal to my exponent, and then I plus plus. All right, and then at each step, I'm going to write p equals p times base. And again, just to sketch this out, suppose my base was 5. The idea is p starts at 1, and then after one iteration of the loop, and if you're confused by this, I encourage you to try doing a full trace of this. It won't take very long, and it's good tracing practice. I start p at 1, and after one iteration of the loop, this p equals p times base would result in, so p equals p times base. Well, p is equal to 1, and the base is equal to, for example, 5, and so p ends up equaling 5, okay? And then at the next iteration, when I do p equals p times base, I'll have 5, which is the current value of p, times 5, which is the value of base, and then it equals 25, and so on. And so I'll get at each iteration, I'll be folding in one more multiple of 5. All right, so I'm just going to try testing this out. Again, on an exam, you might want to test it out manually by tracing through it, but here I have the advantage that I can just run it in JupyterHub. All right, so 2 raised to the power of 3 is 8. And of course, the age-old question, does that mean that we're done? And the answer is no, it does not. We have to we have to do a few more tests to make sure that this seems to be working. So a few tests I'm going to do. I guess the first one is I'm going to try, what if we use a different exponent? Let's do an exponent of 0, because that's a valid exponent. And we know that 2 raised to the power of 0 should be 1. Which it is. Okay, let's see if we do a different power of 2. We'll do 2 to the 10. Now, as a computer scientist, I know a lot of powers of 2. So that's one of the reasons I'm going to keep testing on powers of 2. It's just one of those things you memorize after a while. So 2 to the 10 equals 1024. So we'll try that out. Okay, 2 raised to the power of 10 is 1024. That's sort of reassuring. Now let's try powers of 5, because I guess I was already working with those. So 5 to the 3, that should be 125. Sure enough, it is. And then 5 to the 4 should be 625. And that looks good as well. Are we done? Well, I've tested on 2 different bases. I've tested on a variety of different exponents, and those 2 cases together, I mean the different bases and the different exponents, that should be enough for me to be confident that the code is basically correct, but there are a couple of special cases I should check. So I have tried an exponent of 0. I'm not going to worry about a base of 0, although certainly, because that creates a bunch of other questions that I don't really want to answer in this video, because powers of 0 can sometimes be indeterminate. But one thing I'll observe is that I'm using int. That means that I don't really need to worry about negative powers. So obviously, if I wanted to compute 2 to the negative 2, well, that's 1 over 2 squared, which is 1 over 4, and there's no way that I'm going to store that in an int. And so because ChatGPT gave me the function signature involving ints, I sort of know that this is not a logical input. So I don't have to worry about how am I able to take an exponent of negative 2 and do anything useful with it. So I'm not going to worry about this case. On the other hand, I should sort of worry about a base of a negative number. So negative 2 to the power 3, well, that is something I can compute. That's going to be an integer. So that's going to be negative 2 times negative 2 times negative 2. So I guess I should test that. That's a valid input, so I guess I should test that. So let's try negative 2 to the power of 3. All right, so negative 2 raised to the power of 3 is negative 8. Okay, well, let's just do this by hand. So negative 2 times negative 2 times negative 2. Okay, well, negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is indeed negative 8. Okay, so that looks good. That checks out. We'll try one more. Let's do negative 2 to the power of 4. Now, I'm going to expect this to be positive 16. And it is. Okay, so I think that's enough of a test of negative bases to verify that I put a negative in and a negative comes out in the cases where it's supposed to. Maybe I need a little bit more testing, but that's a very unusual case. I don't have to test that one too exhaustively. So all in all, I think I now have tested enough to make sure that my code generally works. There might still be a bug, but it's unlikely if you were to try this code that you'd find the bug just about instantly, and therefore maybe I would have embarrassed myself by not doing enough testing. So I think that means that we're ready to go on to exercise number 3.